Hey students, in this video we're going to be going through the answer key for the Chapter 5 review number 1. Again, it's review number 1. Please make sure you've attempted all the questions on your own first. You can use this video to help you correct your work. If there's anything that still doesn't make sense at the end of this video, please let me know. Remember, this review looks identical to your test. Your test will have almost the exact same questions, but they'll just be using different numbers, and they will be a little bit easier than the ones on this review. So number 1 asks us to identify the terms, coefficients, I'm spelling that wrong, and constants of this expression. And the expression is 2x squared plus y plus 10. So the terms are the parts separated by addition or subtraction symbols. So first I have 2x squared, then I have y, then I have 10. It's like I took my expression and replaced the plus or minus symbols with commas to create a list of terms, 2x squared, y, and 10. Coefficients are numbers in front of the variables. In front of the x, there is a 2. In front of the y, I don't see anything, but that means there is an invisible number 1 because 1 times y still makes y. And constants are terms that are just a number with no variable attached, so that would be 10. Question 2 asks us to rewrite this expression 5.1 times x times x times x using exponents. So we use exponents when we have repeated multiplication. So x is the thing that's being repeatedly multiplied here. There are 3 of them, so x to the third power. But that doesn't just get rid of this 5.1. It's still getting multiplied by 5.1. So we have 5.1 times x to the third power. We just shortened those x's to x to the third power. And then if I'd like, I do not need to include that multiplication symbol. I can simply write 5.1 x to the third power. 5.1 times 3x's. Question 3 says evaluate 20 minus x squared when x equals 3. So it's basically saying, hey, tell me what this expression equals if x is actually the number 3. So first I'm going to replace x with 3. So instead of x squared, I wrote 3 squared. And then I do need to evaluate this in GEMDAS order. That means exponents come before subtraction. 3 squared means 2 3's multiplied together, 3 times 3, which is 9. So I have 20 minus 9, which is 11. So the value of this expression when x is 3 is 11. Question 4 says write the phrase as an expression. The phrase is a number x subtracted from 75. So it looks like the two things I'm going to be using here are x and 75. And then the word subtracted from is telling me which operation to use to connect these. Subtracted from, that means subtraction. But subtracted from actually means to take the first number away from the second number. It means I need to switch the order here. I do not want to write x minus 75. I want to write 75 minus x. And that is it. It just wants me to take the words and rewrite it using numbers, variables, and operations. So x subtracted from 75 means 75 minus x. Question 6 is again write the phrase as an expression. The phrase this time is 4 more than the quotient of a number b and 3. So it looks like I have a little bit more here. I have 5, b, and 3. Those are kind of the 3 variables or numbers that I'm going to be connecting. And then I have 2 different phrases to connect them. The first is more than. The second is quotient of. So more than means to add. 5 more than means 5 plus the rest of this stuff. The rest of this stuff is the quotient of b and 3. Quotient of means division. That means I'm dividing b and 3. B divided by 3. So 5 more than 5 plus the quotient of b and 3. B divided by 3. I rewrote the phrase using numbers, variables, and operations. Question 7. It tells you that it costs $7 to bowl a game. And then it costs you $5 for shoe rental. We're going to write an expression that represents the total cost in dollars of G games. So G represents the number of games we're going to play. So we want to figure out how can I use these numbers and this variable, G, number of games, to write an expression that will tell me the cost of playing this many games. So first, let's think about the $7 per game part. If I pay $7 per game, what does that mean I'm doing with $7 and the number of games, G? That means I'm multiplying them. $7 times the number of games. $7 for one game, that's $7. $7 for two games, that's $14. $7 for three games, that's $21. Each time I'm multiplying the $7 by the number of games I played, which is represented by G. But we can't forget that $5 for the shoe rental. So I need to add $5 for the shoe rental. The reason the 5 doesn't get multiplied by G is because I only need to rent the shoes once. I just need to pay that $5 once. I don't need to pay it multiple times. I do have to pay for multiple games, but I only pay for shoe rental once. Now, if I'd like, I can remove that multiplication symbol there and write 7G plus 5. $7 per game plus $5 for shoe rental. Question 8 says to simplify the expression using the distributive property. The expression is 4 times the group 5 minus 2x. So a number is touching the parentheses. That means it's multiplied by the group. So I need to multiply it by everything in the group. I'm going to distribute it, multiply it by the 5 and the 2x. So I have 4 times 5 and 4 times 2x. 4 times 5 is 20. 4 times 2x makes 8x. So my final expression is 20 minus 8x. I just multiplied 4 by each thing in the group. Sorry, that was actually question 7 also. That was my bad. Okay, question 8 says to simplify this expression by combining like terms. The expression is 5 plus 4x minus 2 minus x. So this one, there's no distributive property. There's no number multiplied by a group, but I am going to combine like terms. So first I need to identify them. Like terms are terms that have the same variable or have no variable at all. So this 5 has no variable. This 2 has no variable. So those are like terms. I'm going to put the same shape around both. This term has an x on it, 4x. This term also has an x on it. So I'm going to put a circle around both of those, the same shape around those because they are like terms. Now I'm going to go ahead and rearrange the expression to get the like terms next to each other, to get the boxes next to each other and the circles next to each other. So I'm just going to swap the middle two to make that happen. 5 minus 2, it said minus 2 before, it should still say minus 2, plus 4x, it said plus 4x before, it should still say plus 4x, and then minus x. So now my like terms are right next to each other. So I can go ahead and actually combine them now. So 5 minus 2, I get 3. 4x minus x, what is that? Well, if I have just an x alone, that's just 1x. 1 times x is x. So 4x's minus 1x's, that makes 3x's. And so my final answer, my expression, is 3 plus 3x. And finally, question number 9. I have n plus 3 multiplied by the group n minus 1. And I'm going to use both the distributive property and combining like terms to simplify this. So first, I'm going to use the distributive property because I have a number touching a parentheses. It's multiplied by the group. You might be thinking, wait, can I add n and 3 first? Well, in GEMDAS, we would not add first. Adding would come at the very end, so I'm just multiplying 3 by these things, not the n. The n stays separate, but I am multiplying the 3 by both of these. 3 times n is 3n minus 3 times 1, which is 3. Now I can combine like terms, and it looks like the like terms are already next to each other, n and 3n. They both have an n on them. How do I combine those? Well, n alone means 1n. 1 times n is n. 1n plus 3n's is 4n's minus 3. So my final expression is 4n minus 3.